Okay, so I wanted to do one more example from this section, 2.16, finding the height of a leap. A springbok is an antelope found in southern Africa that gets its name from its remarkable jumping ability. When a springbok is startled, it will leap straight up into the air, a maneuver called a pronk. Okay, most of that's just superfluous information in terms of solving the problem. But it's interesting. A springbok goes into a crouch to perform a pronk. It then extends its legs forcefully, accelerating at 35 meters per second squared. Okay, we have our first bit of information here. 4.7 meters. We have a distance as its legs straighten. Legs fully extended, it leaves the ground and rises into the air. At what speed does the springbok leave the ground? So I'm looking for a speed when the springbok leaves the ground. So you can kind of sketch this to get some idea of what's happening. So the springbok is starting with legs bent. Believe it or not, here's a little deer. Oh, does it need a tail? A little tail? That totally looks like a springbok. So here's the start position. And then it's going to end, kind of like in the picture given, with its legs straight. Ears. Oh my gosh. I'm like destroying this thing. Okay. But the point is, right, so if this is my x is equal to 0 axis, then he goes from 0, an initial position, to a final position of 0.7 meters. Okay, so, and I know the acceleration for that time, and I want to know how fast he's going when he leaves the ground. So on the next page, I'm going to make my table of knowns. I know that he's going in the y direction, right? So I can actually draw a motion diagram. He starts here at the bottom, and he gets faster and faster and faster as he straightens his legs like that. So his acceleration in the y direction is 35 meters per second squared. He covers a distance, so you can either write delta x. I like to break it up into my initial position defined as 0, and then my final position is 0.70, in this case, sig figs meters. I know that he starts with an initial velocity equal to 0, and his final velocity in the y direction is what I'm looking for. So I don't have any information about time. That's my missing piece of information. So I'm going to use that equation that I used in the last example, which is Vy final squared is equal to Vy initial squared plus 2ay x final minus x initial. Okay, so I like to plug in things that are 0, like my initial position. This term right here goes away, and my my velocity initial is also 0. And I'm looking for the final velocity, so that's already solved for. So I'm just going to clean this up. This is 2ay distributing this times x final. Let's plug in some values. The acceleration is 35 meters per second squared. And my distance traveled is 0.7 meters. If I put that in my calculator, if I did that right, I should get 49. Now let's check our units. I have meters times meters, that's meters squared, divided by seconds squared in the bottom, and that's my Vy final. So if I take the square root of both sides, right, because this is squared here, then I can get my final velocity. Final. Square root of 49, I know this one off the top of my head. Don't even need my calculator for that. That is 7 meters per second. Now, is that all I was asked for? At what speed does he leave the ground? Yep, that's all I was asked for. So I am done. Does that seem reasonable? Yeah, it's not super fast, but you know, he's only a deer and he's jumping, so I think that seems pretty reasonable.